going to do Ninja Star.
You could.
Okay, just kidding.
But that's a lot of work. What's the first thing we're supposed to do on any factoring problem? GCF. Is there a GCF? Yeah, so let's pull out the 3.
I was just kidding with that.
X squared plus 5x plus 6.
Okay, I need 2 things that add to give me 5 and multiply to give me 6.
Oh, just kidding.
Add to give me 5 and multiply to give me 6.
3 and 2.
2 and 3, perfect. I don't know why I didn't write it the way you said it. So it ends up being 3x plus 2 and x plus 3, and that's all equal to 0. Okay, yesterday we started talking about something called the quadratic formula. You have out your yellow sheet. I'm going to take John David. John David, can I have your yellow sheet? We were given a quadratic equation in standard form. We identify the A, B, and C. We plug in, chug, and get out answers. John David, can I have your monkey? The hardest part of the quadratic formula is remembering it. We had discussed that yesterday. So thankfully, John David's left me some room. Notice that we have ax squared plus bx plus c equal to 0. So the first thing I need to suggest with your monkey, if you didn't already do so, is that each equation must first equal 0. So for instance, on number 6, John David needs to subtract 10 from both sides first. Then he has 3x squared plus 9x minus 12 equals to 0. Now he can finally use that quadratic formula because he knows the A, the B, and the C. So there's potential, if you worked this last night and you did not move that 10 over, you still picked A was 3, you still picked 9 was B, but for C you picked negative 2 and it was supposed to be negative 12. So on each equation, make sure first you set them equal to 0 because that's what we wrote first in our notes yesterday, and I guess I didn't make a big enough deal about it. Notice our standard form equation is equal to 0 first before we pick the A, B, and C. Okay. Were there any questions about just like how the quadratic formula works or something about the quadratic formula, not about specific problems on the color by number? Yes, dear. Yes. If you did the minus 2 instead of the minus 12, you're going to get the wrong numbers in your formula. So you'll have to fix it. Okay, the next thing I would want to say, and this is Rex's point yesterday, he makes a very fine point because we've spent so long factoring, and once you pull out a 2 and make it a 3x squared plus 5x minus 12, Rex can ninja star this probably faster than he can actually use the quadratic formula. So his question was, why then? Why use the quadratic formula? It's a good question. So my first note to you and me, I'm so old we didn't ninja star. We used to do something called guess and check, so factoring took a lot longer. So the quadratic formula was faster for me. I get why it's not faster for you. The purple sheet is going to shed a little light on why we use that quadratic formula. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay, so the purple sheets that we skipped yesterday, it's going to help us shed a little light on why that quadratic formula might actually be useful in life and why we might like it more than factoring. And the reason we're going to like it more than factoring is it tells us more about the graphs than factoring does, in that to find the roots with factoring, you actually have to factor. To figure out where those roots might be with the quadratic formula, you don't actually have to go through all the steps of the quadratic formula. Okay, so we see something at the top. It's called a discriminant. It says the discriminant is b squared minus 4ac. Where in the quadratic formula do you see that discriminant? Yeah, it's under the radical, under the square root. So we know the whole quadratic formula. This part, under the square root, has a name, and it's called the discriminant. Now, I'll forgive you if you don't remember that term from me. But I swear, if you just go ahead and put that one to memory, it will be very useful in algebra 2 with trig. Okay, so we're not actually going to go through all the steps of the quadratic formula. We're just going to find the discriminant. And once we know a number for that discriminant, that tells us about the graphs. So let's just start with the first one. What is the A, the B, and the C for my first example?
A is 2, B is -8, and C is -42.
Okay, so if I'm doing the discriminant, which is B squared minus 4AC, what would I have for in the B again? -8 squared, which would be what number? -8 times -8 is -64?
64.
It's positive 64. -8 times negative positive 64. Okay, and then AC, so my A was 2. My C is -42. Again, just a tiny forgetting that sign error could be a big deal for us with the quadratic formula. Let me zoom in a little. Okay, so we figured out our B, our A, our C. We're plugging it into this thing called the discriminant. I need to know -4 times 2 times -42. But it'd be positive because I have a negative times a negative, so it ends up being a positive. So I add 64 and 336, and what do you get? Okay, tell me about that number. Is that, actually, we'll just stop right here for a second. Is there any question about how I got to 400? Well, then before we get to why that's useful, let's go ahead and do it with the others too. So I need to know the B squared minus 4AC. So what would B squared be in my second example? Okay, -18 squared. What would the A be?
30,
What would the C be?
27.
Okay, so I need to know -18 squared. Is it -324? She said -324. Is that correct? No, because a -18 times a -18 is going to be a positive 324. But otherwise, she's there. But that tiny sign error is going to mess us all up. And then I need to know, ma'am?
That's equal to 0. It's 324 times
4 times 3 times 27 is 24. How come on our last example we ended up adding, but on this one we still subtract?
Because the signs are different on this one.
The signs are different on this one. On our last example, the C was negative. On this example, our C is positive. The C was negative. It was -42. The C is positive. It was a positive 27. Okay, so I get 0. And then for kicks, let's go ahead and do the third one. So B squared minus 4AC. What is my B?
9 squared,
Which is 81. Thank you, ma'am. She's jumping the gun. I like it. 4. What is my A?
2,
What is my C?
16,
So I need to know 4 times 2 times 16. So you did 81 minus 128, and what did you get? Say it again. Okay, Miss Cumden, that's great. Why are we calculating this thing called a discriminant? What does 400 or -47 mean to me? I don't understand how that has anything to do. You're saying it somehow ties to the graphs, but I don't understand how or why. Look, I'm about to fill in those blanks. Does anyone have a question about how we got 400, 0, or -47?
You have to draw those graphs?
Yeah, you probably want to help yourself. Ma'am, which one?
When we get to that answer, do we have certain zero still? Or do we just have that answer?
I'm about to reveal all my secrets.
I like the numbers.
Now, on your color monkey thing, do you just do this? No. You have to do the full out whole quadratic formula. Because what we're doing does not tell us exactly where those zeros are. You'll have to use the full out whole formula, not just that discriminant, to figure out exactly where. Like it crosses here and it crosses here. You'll have to use the quadratic formula to figure out exactly where. But that discriminant does tell me how many times it crosses. I'll say that again. The discriminant tells me how many times my graph crosses the x-axis. If my discriminant is positive, like this one, then my graph really is going to cross that x-axis twice. If my discriminant is positive, because we got a big number, it was bigger than 0, we are actually going to cross that x-axis twice. And it even says that. It says 2 real solutions exist, meaning we cross the x-axis twice. The next column where we're equal to 0, it says 1 solution exists. What does that mean? It only crosses it once. We had a special term for that. No, we do call that the vertex. So it crosses at the vertex, but we called it something root. It had a word. It started with a D. A D.
Direct root.
It was called a double root. We talked about that. Why would it be called a double root? That's a very good question. So, I can show you why it's called a double root. So, probably what happened is if we factored it, so we had some equation like x squared plus 8x plus 16. Some quadratic equation like that. And we factored it, and lo and behold, it was a special product, and it actually ended up being x plus 4 twice. So x plus 4 squared. That's how we got a double root. Do I expect you to remember all that? No. Again, the main point of the discriminant is to figure out how many times did it cross. If you get a bigger number than 0, it crosses twice. If you get a number equal to 0, it crosses once. And if you get a number less than 0, what do you think happens then? It doesn't cross at all. So it could look like this, for instance. Or it could look like this. Or even this. It can look like anything as long as it doesn't cross that x-axis.
Even if there's a point on it.
You'll notice it can cross that y, but there's none of my examples are crossing that x-axis on that third column. Cannot cross that x-axis because there is no real solution. Okay, Ms. Compton, that's great. Sounds nice. Sounds great. That doesn't help me. You told me today I was working on my monkey. How does that help me with my monkey? Again. Huh? There is the one with no solution. So it doesn't cross, so there's no solution. So let's go back again. Remind me again, where do you see that discriminant in the quadratic formula? Under the radical. So if you're getting a negative under the radical, so I'm going to flip to the back and work something out. I'm making up stuff. So she's working stuff out. She gets like negative 47 plus or minus square root over 2a. I don't know why that was her b squared. That doesn't make sense. We'll make it a negative 16. Because if it was squared, it needs to be a pretty square. I put it on the back. I'm just putting an example on the back to prove what Natalia and Allison are catching on to, and I need you to catch on to too. On to too. Lord, that's confusing. Okay, so let's pretend that somehow I was using the quadratic formula. And this is me. I'm chugging along with the quadratic formula. And I got to here, and I had this number underneath my radical. What do I do then? Do I know how to do the square root of a negative number? No. So what answer should I pick? But again, that ties to my discriminant. My number under the radical, which is called a discriminant, it was less than 0. So as we just discussed, that means on my graph, it's never crossing that x-axis. Saying all that, there is one on your paper that has no solution. Obviously, there's one on the monkey that's no solution because the answers are down at the bottom. So Josh is in a hurry. He wants to get his monkey done. He doesn't like coloring things anyway. He just wants it done, over with. True. He gets negative 49. He selects no solution, and then he goes to the next one and he gets a negative number, and there's only one no solution. What has possibly happened to Josh? Could he get no solution twice?
Yes.
In real life, yes. On the monkey, is he supposed to get no solution twice? No. So what does that mean Josh made?
A mistake.
He probably made, be specific, what kind of mistake did he make? He probably made a sign error. He did a negative times a negative and didn't get a positive. He did negative 16 squared and still got a negative number. He made a sign error. He needs to get it together. Okay, are there any questions about us in the quadratic formula? Ma'am.
Okay, so I worked the worksheet, like one of the problems from the homework.
Okay, which one?
Number 1.
Okay.
Okay, and so I set it up and everything, and then I got, I think it's 6. Negative 2, or x equals negative 2 plus or minus 6 over 2. But then once I separate them, I don't know what to do down there. Like once I separate them into like negative 2 plus 6 over 2 and then negative 2 minus 6 over 2. I don't know what to do from there.
You had negative 2 plus or minus 3b squared minus 4ac over 2a. So negative 2 plus or minus 4 plus 32. So you ended up with 36 under the radical. You didn't end up with 36 under the radical?
I typed it in just how I wrote it, and it came to 6.
Oh, because that is, square root of 36 is 6. So you got to negative 2 plus or minus 6 over 2?
Yeah, and then I separated it, but once I separated it, I don't know what to do.
Solve. So negative 2, so you did negative 2 plus 6 over 2 and negative 2 minus 6 over 2. So you have 6 minus 2 is 4. So 4 over 2, which is just 2. Negative 8 over 2 is just negative 4. Keep going. Combine the like terms in the numerator. I need to give you a new one, John David. I forgot it was yours and wrote all over it. Yes, dear.
You said that we had to set it to
Yes.
0, right?
Yes.
I didn't set it to 0 and I still got the right answer.
It's a miracle. You should have to set it to 0 in order for it to actually get the right numbers plugged in and out of the quadratic formula. And are you sure you have the right answers?
I got 2 and 4.
Okay, let's look. Number 6 or number 1? Number 1 is already set equal to 0. So you're going to go. Number 2 wasn't set equal to 0. We would need to fix like number 2, number 6, number 8. We would have to fix all the ones where it's not, like that one's equal 0, so it's fine. That one's not equal 0. Let's move it first. Okay. So yes, your one's right.
What do you mean? Like subtract?
Like add 10 to both sides. Like move everything to one side.
Okay.
Move everything to one side. Okay.
Square root of